A pulley with a radius of 16 inches uses a belt to drive a pulley with a radius of 33 inches. The 16-inch pulley turns through an angle of 210 degrees. Find the angle through which the 33-inch pulley turns. Let's start with just a little picture so we can understand what's happening here. We'll do a side view of our pulleys here. And so we've got two different sizes. Here's our 33-inch pulley and here's our 16-inch pulley. And I'll go ahead and just draw those radii here. 33 and 16. And we've got a belt connecting these, and so our belt is like this. Okay, wrapped around these two pulleys. We know that the 16-inch pulley turns through an angle of 210 degrees. So if I draw that 210 degrees, okay, we could say it turns like this, say, and 180 is a full half circle, I should say. So it actually goes to maybe somewhere around here. Okay, so it turns this much, meaning that this much of the belt, what I've highlighted here in red, is the amount that moves. Okay, so the question is, what's that distance in the belt? Well, we have that arc length is equal to the radius times the angle. Okay, and this angle generally is measured in radians. Okay, now we want to know how much this 33-inch pulley will rotate, and really we know that the arc length is the exact same for this, right? The length of the belt that the belt moves through this pulley will be the same as it does over here. So we actually have a really nice relationship where we can just set this r times theta equal to r times theta for the other pulley. So for our first pulley, we have our radius of 33 times the angle that I don't know equals the radius over here, 16, times the angle over here, which is 210 degrees. Okay. Well, now to solve for this theta, I could just divide both sides by 33. So divide by 33, divide by 33, and that's going to tell me theta, and it's going to give me a degree measurement since that's what I used over here. So I'm going to go pull my calculator in now and type that. So I've got 16 times 210 and then divided by 33 and hit enter. And this is not quite simplified actually. I'm going to use my simplification button to simplify that. And then, so this is a mixed number, and if I wanted an improper fraction, I could do that here in the calculator as well. Okay, and that gives me an improper fraction that represents the angle. I could also get a decimal if I'd like. Okay, and this would be the decimal form of my degree measure for the angle.